If your e-bike battery is not holding charge, the first trap is assuming the battery itself is the problem. A no-charge symptom only tells you the power path failed somewhere. That could be the charger, the port, the pack, or a protection circuit inside it. So before you buy anything, start with the symptom you can actually see, then trace where the charge process stops. Think of the bike as one chain that has to cooperate. Power starts at the charger, passes through the charge port, reaches the battery pack, then goes through the BMS, controller, display, and finally the rest of the bike. If one link breaks, the whole system can look dead or weak. That is why a battery charge problem is not proof of one bad part. Inside the battery pack, the story gets more specific. The pack is not just one solid block of power. It contains cell groups and a protection board that watches what is happening inside. So the outside symptom can mean a simple connection issue, or it can mean the pack is protecting itself because something inside is not behaving normally. Charging is not just sending electricity down a cable. The charger has to see a clean connection and a battery state it considers safe before current should flow. If that handshake does not happen, the light may stay wrong, charging may not start, or the process may stop early. That is why the charger's behavior is evidence, not just decoration. Now look at the charge port closely. A dirty port, a bent contact, moisture, or a loose fit can imitate a bad charger or a bad battery. This is one of the fastest checks because it is visible and cheap. If the connection cannot stay solid, the charger never gets a proper path into the pack. Inside the battery, the BMS acts like a gate. It watches for conditions that could make charging unsafe. If it sees a problem, it may block current even when the cells are not completely empty. So if the bike refuses charge, do not force the next step blindly. The protection board may be doing its job. The display and controller can still give useful clues. If the display behaves oddly, drops out, or never wakes normally, that can point to more than one place in the system. But it does not prove the battery is bad by itself. It just tells you where the signal path may be breaking as power moves through the bike. In a normal system, the path is clean. Power moves from charger to port to pack, and the expected light or charging response follows. In a fault, that flow stops, flickers, or branches off before it reaches the destination. That visual difference matters because the symptom is the same at the handlebars, but the cause is not. Start with the outside of the bike before opening anything or ordering parts. Check for obvious damage at the port, the cable, and the battery mount area. Look for loose fit, corrosion, pinching, or anything that suggests the connection is not stable. These safe checks are useful because they can explain the symptom without touching the risky parts. Now watch the charger light behavior. If it changes the way the manual or the charger pattern suggests, that gives you one kind of evidence. If it does not change at all, that does not automatically prove the battery is dead. It still leaves the charger, the port, and the battery side path in play, so the fork is not finished yet. Next, check how the battery seats on the bike. A rail problem, a latch problem, or a worn contact point can break the connection even when the pack itself is fine. That is why the battery can look guilty when the real issue is the bike side contact path. The symptom is the same, but the failing boundary is different. Pay attention to extra clues like intermittent lights, sudden dropouts, heat, odor, or swelling. Those details change the decision boundary. A bike that briefly works and then fails is not the same as one that never responds at all. And if you notice swelling or a damaged battery warning, that is not a normal troubleshooting branch. This is where people waste money. They buy a charger, a battery, or even a controller before they prove the failure path. But a replacement only helps if you know which link is actually broken. If the evidence is still unclear, the smarter move is to keep testing the path, not to guess at the most expensive part first. If the battery shows swelling, heavy heat, odor, leaking, or signs of exposed damage, stop the home check there. Do not keep forcing charge tests or opening parts that are not meant for user service. At that point, the question is no longer just performance. It becomes a safety issue, and that changes the next step completely. Different e-bike designs move the same basic system around in different ways. The charger path, the battery mount, the control unit, and the display link may be arranged differently from bike to bike. So the general map helps you orient yourself, but the actual layout decides which safe branch you should check next. That is why model-specific detail matters. At this point, use the evidence you have. If the charger behavior points to the charger path, follow that. If the port or seating looks weak, stay on the bike side contact path. If the pack shows warning signs or the result is still unclear, that is where professional verification makes more sense than guessing. The goal is to match the action to the evidence. Remember the order. Start with the symptom, map the power path, make the safe external checks, then use the evidence fork before replacing anything. That sequence keeps you from turning one charging problem into 3 expensive guesses. And if the bike shows risky signs, the right move is to stop, not push harder. The process has to fit the evidence. If you want the full charging checklist, check the related guide. And if your exact model is acting up in a specific way, leave a comment with the model and symptom. That makes it easier to sort out whether you are dealing with the charger path, the port path, the battery path, or something that needs professional help.